Hi guys, Mr. Townsend here, just to do a quick little video about balancing chemical equations. Now, there are a couple things you can do to make your job a little bit easier, and I'm going to try to show you some of those tips and tricks in this video. First of all, we're going to start off with our chemical equation here, and I'm going to use a pretty common one that you see in examples in many different worksheets. We're going to start off with PbNO3. And that's going to give us some amount of PbO plus some amount of NO2, as well as a little bit of oxygen. What we're going to do is we're going to balance this chemical equation, and I'm going to give you a couple tips and tricks along the way. So a couple things that I always recommend that you start with is creating a list of elements for both of the reactants and the products. Just in case you need to remember, the stuff over here, this stuff right here, these are the reactants. And over here is the products. Also note that the law of conservation of matter states that whatever we begin with over in the reactants, we have to end up with the same amount of mass in the products. That's why we're balancing these equations, so we can see how much of each is required in order to keep that balanced. Okay, so let's go ahead and make a list of our reactants first. Now, what I'm going to be doing is I'm going to be listing out all of the elements that are present on this side. So we have lead, we have nitrogen, and we have oxygen. Now, over on the product side, I'm going to do the same thing. So I have lead, I have nitrogen, and I have oxygen. But oxygen's a little different. I'm seeing that I have oxygen in 3 different places, and each of the oxygens here are actually separated out by a plus sign. This is important because I can actually use the fact that they are separated out by a plus sign to list them separately on my list here. Now, it's not required, but it will make it a little bit easier for us to figure out where to put our coefficients if we know what part of the equation it is currently affecting. So just for the sake of this little video, I'm going to put little color codes to indicate which O's correspond to the ones in the product side. Now, I just want to be clear that if these O's were not separated by a plus sign, for example, if we had something like NO2 parentheses OH in parentheses, we wouldn't separate out those O's. We only want to separate out the elements that are separated by a plus sign and are the same. So if there are 2 or more of the same element and they are separated by a plus sign, list them separate like I did in this example for the products. Okay, let's go ahead and tally up how many of each element we have. So over here on the reactant side, I have 1 lead, I have 2 nitrogen, and we have 2 nitrogen because this subscript 2 actually distributes to everything inside of the parentheses. So I have 2 nitrogen, and since this subscript for the oxygen is there, we actually have 2 sets of 3 oxygen. So that means we actually have 6 oxygen on this side. All right, let's go ahead and take a look at the other side. I have, once again, 1 lead. I have 1 nitrogen. My red O's, I have 1. My blue O's, again, we have this little subscript there. So I have 2 oxygens there. So for the blue one, I have 2. And then my green one, I have 2 as well because of the subscript. Now, even though I have all these oxygens listed out separately, I am keeping track of the sum of those oxygens, and that's what I'm going to compare to this number on this side. So I'm trying to get a total of 6 oxygens, or possibly a different number. But I'm not going to be looking at just one of the oxygens here. I'm going to be looking at all of the oxygens, and I'm going to look at the sum of it. All right? So I'm going to be looking at the sum of all of these oxygens. So even though they're listed separate, consider the sum of those elements when balancing. All right, let me get rid of those green boxes. Okay, so I have actually 5 oxygens in total over here, and I'm just going to put that in a little bracket just to remind us that we have 5. All right, well, let's get to balancing. My first step in balancing chemical equations is to look at sort of what I'm going to call exotic elements. That means they're just elements that aren't hydrogen, oxygen, or atomic elements that are just sort of by themselves. An example of these sort of atomic elements or molecules, like this oxygen over here, since it's by itself and it's just oxygen, we're going to ignore that one until the very end, because that one is really easy for us to change if we need to. All right, so I'm going to go ahead and start with lead. As I look at lead, or Pb here, I can see that the lead is actually already balanced. I have currently 1 lead on this side and 1 lead on this side. So I can go ahead and move on to the next element. My next element is nitrogen. Now over here on the reactant side, I only have 2 nitrogen, whereas on the product side, I have 1 nitrogen. So when it comes to balancing out these equations, we're going to look at the side that has less and try to bring it up to a number that matches the other side. So in this case, there is 2 on the reactants. I'm going to try to bring up the 1 on the product side to match what's on the reactant side. So I can do that by adding a 2 here. Putting a 2 here will change my nitrogen on this side to a 2, but it also changes this blue oxygen, right? Because the coefficients are actually distributed throughout the entire compound. So this oxygen, this blue oxygen, is actually going to change into a 4. And this is going to change our overall total of oxygen on this side to 7. So I'm just going to keep track of that total over here, right? Because 1 plus 4 is 5 plus 2 is 7. Okay, so now I have 1 and 2, but now I have 7 total oxygen versus the 6. Well, this is going to get interesting really quick because I only have 1 compound on this side, on my reactant side of the equation. So I'm going to have to find a way to increase the oxygen and then balance out the rest of the elements, because now that's going to be an issue. So watch what I mean. If I put a 2 here, if I put a 2 there, now it's going to change my lead, nitrogen, and oxygen. So that means I'm going to have to balance the other side again. And we can't put fractions over here. We can only put whole numbers. So you cannot use fraction, only use whole numbers. So if you can't balance it on one side, try changing the coefficients on the other. So let's just go ahead and recalculate what we have here. So I have 2. This 2 now distributes over here as well. And we have the 2 on the outside. So we have 2 groups of 2 nitrogen, so that's 4. And then we have our 2 groups of 3 oxygens. So 2 groups of 3 oxygens. That's 12, right? Because 2 times 2 is 4 times 3 is 12. Oh man, well now I've got a whole mess of stuff over here on the reactant side, and none of it balances over on the product side. That's okay, we can make some changes as well. Let's go ahead and start with lead, or Pb. Since now it's 2 over on the reactant side, I need to make sure that it is 2 on the product side. I can easily do that by putting a 2 here, which then distributes to the lead and red oxygen. So I can change this to 2, this to 2. Now I have 2 plus 4 is 8, or sorry, 2 plus 4 is 6, plus another 2 is 8. So now I have 8 oxygens total. Let's see, so now I'm at 2, 4, okay, so my nitrogen needs to be balanced out, because on the reactant side I have 4, on the product side I have 2. So I'm actually going to erase this other 2 that I had. All right, we don't need that anymore. And I'm going to replace it with the next number up, a 3, right? Because we can only do whole numbers, and I can't do like 2.5 or anything, so the next number up would be 3. Let's see what happens. If I put 3 here, that's going to give my nitrogen only to the number 3. And I need to reach 4, so 3 is not going to work. 3 is not going to work, but that's okay. We're doing trial and error here. Let's go ahead and just jump up to 4. We'll jump up to 4, because now if I do that, this turns into a 4. The blue oxygen is now 4 times 2, because remember it distributes. So 4 groups of 2 oxygen, that gives us 8. And then that's it for that one. So let's go ahead and reassess our tallies here. I have 2 leads on each side. I have 4 nitrogens on each side. And now with this 8 here, 8 plus 2 is 10, plus 2 is 12. My new total of oxygens is actually 12. And that matches the 12 over on this side. This is our balanced equation, with of course our 1 set of oxygens over here. So if you end up not putting a number in any of the spaces and you need these numbers to stay balanced, just put a 1. A 1 is not going to affect the amount that you have, because 1 times anything is just the thing that you have. So if you have any blank spaces afterwards, after balancing this out, make sure you put a 1 there so it doesn't affect your numbers. Okay, so this is just the quick little rundown of how to balance out a simple chemical equation using a couple tips and techniques. I hope you enjoyed. Let me know if you have any questions.